Hello, this is Anna Johnson and my Lab 1 presentation for Physics 2. This lab centered on exploring the interactions of charges and electric fields with common household items. It focuses on the goal of finding an amount of charge on a charged piece of Scotch tape, as well as examining how it interacts with objects around it. Some fundamental concepts used were Coulomb's law, electric field superposition, and gravity. And the tape was found in the end to have a charge of 5.271 times 10 to the negative 9 coulombs. And then the diagram on the left shows how the lab was performed. So to accomplish a charge on the tape, one piece was pressed flat on a surface and another laid directly on top of it before rapidly being pulled off to give it its charge. And then in the other diagram, the two tapes, which are assumed to have equal charges, were shown with the top one being repelled by the bottom one from its starting position. So some data and measurements. The tape lengths were both 8 inches, and then the mass of the top tape was found to be 2.032 times 10 to the negative 4 kilograms, using the conversions shown. And then the separation distance between the two tapes repelling each other was 1.12 centimeters. And then the charge of the top tape was found by setting the gravitational force equal to the magnitude of the electric force that's acting on the top tape. And a key assumption is that the two tapes were treated as separate point charges that were equal in magnitude. And so below is the equation, and Q is found to be 5.271 times 10 to the negative 9 coulombs. So the total number of atoms was found by first calculating the surface area of the tape and then dividing by an estimated value of an atom's surface area, before then dividing the number of electrons, which I found using the method below. Atom length was assumed to be 1 times 10 to the negative 10 meters, so radius of the atom was half of this value, and the assumed surface area equation of a sphere was assumed to be the same as an atom, which is 4 pi r squared, and so the total atoms was found to be 1.643 times 10 to the 17 atoms. And then the number of electrons was found by dividing the total charge by the charge of one electron, and so that was found to be 3.94 times 10 to the 10 electrons. And then the ratio was found by dividing the number of electrons by the total number of atoms, which was found to be 2.005 times 10 to the negative 7. So some observations. Objects that attracted the charge tape were my notepad, my hand, my phone, one of my stuffed animals, and a negatively charged pen. And an object that repelled the tape was another charged piece of tape. And so because the tape was attracted to a negatively charged pen, this suggests that the tape has a positive charge. And then the fact that another piece of tape repelled it suggests that the two tapes have the same charge. And then some questions from the lab instructions. If a U-tape is positively charged, how to interact with a charged plastic pen? It would be attracted. If negatively, it would be repelled. And then if it was neutral, it would still be slightly attracted to it. And then this is my glow script code and modeling. The blue spheres represent the tapes as individual point charges, and the yellow arrow as the gravitational force on the top tape, and the red arrow is the electric force exerted on the top tape by the bottom tape. And then some conclusions. So we modeled the interactions of charged objects and observed them in the real-world environment. The most surprising thing about the lab was that the charged objects being attracted to neutral objects. I didn't really expect that. And then the real challenge is making the tape float at the end. It took a couple tries. And then some follow-up questions: if electrons had a positive charge and protons had a negative charge, and then how would that change the observations? To answer that, I would expect the U-tapes to have a negative charge and all the observations would be reversed. However, the U-tapes would still repel each other because they would still have the same charge. And then why is it important to handle the charged tape as little as possible, and what happens when the charged tape comes in contact with hands and other objects? So to answer that, it's important not to handle them because the more you do, the charge, they lose more charge, and also when they interact with other objects, they continue to lose charge. And then, I put challenges twice, so it was really challenging making the tape float at the end. And then that is all. So thank you for listening.